Welcome to the session. So, before starting the formal uh, content of the course, let me first describe something about this course. This course is titled Fundamentals of Business Mathematics, and in this course, we will discuss 4 units. Unit 1 will include differentiation and its applications in business. Unit 2 will include integration and its applications in business. And Unit 3 and Unit 4, we will discuss the concept of matrices and determinant separately, and then we will see how these two concepts can be used to find out the solutions of the various kinds of simultaneous linear equations. And the simultaneous linear equations play a very prominent role in the area of business and management. So it's all about the content of the course titled Fundamentals of Business Mathematics. So we will begin our first unit, that is differentiation and its applications in business as well as management areas. So we will begin our session with the formal definition of a set. So before having the formal definition of a set, let us take these few statements. In mathematics, we use the word set for any collection or assemblage of things. It may be real or conceptual. You can think of a set of dishes, a set of tools, or a set of animals, and so on. There are also sets of things which are physical in nature. The set of rules for a game is an example of a set of ideas. The members of a set need not be alike. One have a set that includes any item like pencil, book, cup, etc., or any animal like cat, etc. So what does these 3 or 4 lines actually represent? We very commonly use the word set of dishes, set of tools, set of animals. So from these examples, we can very easily observe that the term set is not a common word. Rather, it's a mathematical term or mathematical word. And naturally, if it's a mathematical word, then it must have its specific definition. So as far as the formal definition of a set is concerned, it is defined as follows. A set is a collection of well-defined objects. Right? Now look at this definition. What does it mean? Here in this definition, we have used 3 words: objects, collection, and well-defined. Clear? What is the meaning of objects? Objects may be item. They may be dead or alive. It's your choice. You can choose any type of item. There is no restriction on the items. Second word is collection. Collection simply refers congregation or assembly, right? So how many objects you have collected? Okay, how many objects you have collected? If this collection is well defined, then we call such a collection as set. If it is not well defined, it cannot be considered as a set. So the technical term or the mathematical term here is only well defined. Now let us have the formal meaning of the well defined. By well defined, we mean that it must be possible to tell beyond doubt whether or not a given object belongs to the collection that we are considering. So what this statement indicates actually, there are many ways we can identify the meaning of well defined. One way is what? Whatever items you have collected, if you are picking up any single item, the picked up item must be easily identified as from such a particular known collection this item has been drawn. This is the meaning of this line, what we have referred to. This, right? Number 2, whatever items you have collected, in another way, you can also interpret the same statement in this way: whatever items you have collected, try to choose a common characteristic among all those items, and the common characteristic or the common property which you have chosen, it must be either globally accepted or it must be in terms of quantitative representation. We don't have any space when we are defining set for quality wise, because quality vary from person to person. Clear? So whatever items you have collected, it's your choice. Any collection of item is called a set if it is well defined, and the meaning of well defined is simply what? Whatever items you have collected, try to obtain the common characteristic possessed by all the items which you have collected, and the characteristic or property which you have chosen among all the items, it must be either globally accepted or it must have its quantitative representation. So if any collection satisfies this condition, then we say that the given collection is well defined, and naturally if it is well defined, then it is called a set, and if it is not well defined, it cannot be considered as a set. So this is the formal idea how we can define a set, right? For example, the following are well defined collections, and so are examples of the sets. Number one, the set of numbers 1, 3, 5, 7, and 15. So naturally 1, 3, 5, 7, and 15, we know that all the items here, items are number. They all are numbers. Everybody knows that they all are numbers. That is why the collection of 1, 3, 5, 7 being numbers are more concretely being natural numbers. This is a well-defined collection, therefore it can be represented as a set. Collection of vowels in an English alphabet. We know there are only 5 vowels: A, E, O, I, U. If we collect all these 5 vowels, then vowel is vowel, it will remain vowel globally. It cannot be changed, right? So collection of vowels is also an example of a set. Collection of colors in a traffic. The collection of colors in a traffic, they are also well defined. So that is why this collection is also called as a set. So these are the 3 examples which will illustrate the basic idea of the definition of a set. Okay, so before proceeding further, let me explain once more. Simply, the meaning of a set is what? Whatever items you have collected, the best way to identify whether a given collection is set or not, whatever items you have collected, choose a common property or choose a common characteristic among all the items, and that common characteristic must be either globally accepted or it must have its quantitative representation. If any one of these 2 conditions are satisfied, then the collection is said to be well defined. If not, it is not well defined, right? The following do not describe a well defined collection, and so are not the examples of the sets. 1. The vegetables which taste good to all. Is it? This is a collection of vegetables whose taste is good, but the tastes vary from person to person. Any vegetable may be good for me, it may not good for you, also it may not good for any third one. So we cannot say that the collection of all vegetable whose taste is good is not a well defined, therefore it's not a set. Collection of all beautiful women of the world. Of course, this is also a collection of beautiful women, right? But what this collection shows, this collection is not well defined because beauty is a subjective term. Beauty is a qualitative term. It varies from person to person. A woman may be beautiful for me, it may not be beautiful for you. So that is why This collection is also not well defined, so it is also not a set. Example 3, collection of good movies. How you will define a movie is good or not? Every movie will vary from person to person. I may like a movie, but you may not like it. So it is also subjective criteria or qualitative. And what I have told you, whatever characteristic, whatever property you have chosen among all the items, it must be either globally accepted or it must have its quantitative representation. Only then we will say that such a collection is well defined. If not, it is not well defined. Okay, the symbols N, Z, Q, and R, they all are very standard symbols. You all have studied at your 10th or 11th standard. N is known as set of natural numbers. Z is known as set of integers. Q is known as set of rational numbers. And R is known as set of real numbers. So the symbols N, Z, Q, and R will usually reserved for sets of natural number, integer, rational numbers, and real numbers respectively. They all are the best examples of the set N. Natural number means the numbers which are positive and greater than 0. That is 1, 2, 3, 4, and then up to Z. And then Z is what? The numbers positive and negative including 0, right? And then so on. And then Q, the numbers of the type of P upon Q, where Q is not equals to 0. The numbers which are in the form of a numerator and denominator, such that denominator must be non-zero, and R is the sum of all these three numbers. So these are best examples of the set. Why? Here objects are what? Objects are 1, 2, 3, 4. Every object of N is a natural number. We know that. That is why the collection of these numbers is well defined. Likewise here, every object 0 plus minus 1 plus minus 2 plus minus 3, every object of Z is an integer. Therefore, this collection is also well defined. Finally, Q, the numbers of the type of P upon Q. Every number of the type of P upon Q we know is a rational number. Therefore, the collection of all such type of numbers are also well defined. And likewise, R is a mixture of all these three N, Z, and Q. So R is also a set. So N, Z, Q, and R, they are considered as standard examples of the set because they all are satisfies the definition or the formal definition of a set. That is why we use the word set of natural numbers, set of integers, set of rational numbers, and set of real numbers. Sets are generally denoted by capital letters, right? Capital letters, you can take X, you can take A of your own choice. Any capital alphabet, we can represent a set. And the objects of the set are also called as members or elements of the set and are usually represented by small alphabets of English literature or number or any other symbol, right? But the set itself is represented only by capital English alphabet. Second thing is what? Once a collection of objects become a set or becomes well defined, then we call it as a set. When we are talking about set, then we are not using the term object, then we will use the word member or element, right? What does it mean? N is set of natural numbers like this, say 1, 2, 3, 4, 5, right? 1 is a member of N, or 1 is an element of N. 2 is a member of N, or 2 is an element of N, right? Likewise, 5 is a member of n, or 5 is an element of n. So throughout this slide, I will not use the word object, because object we will use the word till it doesn't become a set. Once the collection of objects becomes a set, the objects will be treated as members or elements, right? So the objects that belongs to a set are called members or elements of the set. The Greek letter epsilon is used to belong to. In the next slide, we will use this sign. This is known as epsilon, and the meaning of this is what? Belongs to. Belongs to means member of or element of, right? How we can represent a set? Naturally, this is the next question. So there are two forms a set can be represented. Number one, tabulation form. In this form, we define a particular set by actually listing its element. Simply the elements are listed. What does it mean? Whatever elements you have taken, for example, 1, 3, 5, 7. I have taken these four numbers as a collection, and this collection is well defined because they all are natural numbers, right? So how we will write it? I have told you the set itself is being represented always by capital letters, and their elements may be represented by either numbers or small alphabets of English literature or by any other symbol, right? So 1, 3, 5, 7 is a collection of numbers. So what we do, the elements of a set are being separated by a comma. Means in between two elements we will always use a comma. 1, 3, 5, 7, right? Enclose them in a bracket like this. This is the tabulation form. Enclose all the elements within a bracket like this. So 1, 3, 5, 7 is now a set. Now this as a whole is being represented by any capital alphabet, A or P or X, it's your choice. So this is how we write in tabulation form, and how we read it. A is a set containing four numbers: 1, 3, 5 and 7, right? This is how we read. Here 1 is an element of A, 3 is an element of A, 5 is an element of A, and 7 is an element of A. Number 1. I have told you the symbol this. This means belongs to. So how we write it? 1 is an element of A, then we write it as 1, this symbol A. It means 1 belongs to A, right? Likewise 5, this symbol A, it means 5 belongs to A, right? This is how we can use the symbol in context of the set, right? If a set contains many elements, then the example of the set of English alphabets. For example, we are collecting 26 alphabets of English literature. So we cannot write down all these 26 alphabets directly. So what we will do, say A is what? Is a set itself, A, B, C, and then we use 3 dots, and finally Z, right? An ellipsis, the dots are known as an ellipsis, is a signal that some elements have not been listed. These 3 dots in between C and Z, they shows that in this space there are some elements which we don't list them, or which we don't write. If we wish to list the members of a non-ending set, non-ending set means a set whose elements are never terminating. For example, the set of numbers used in the counting 1, 2, 3, 4, etc. called the natural numbers, we use 3 dots in the end and write it as follows. What is this? N is a set of natural numbers, say 1, 2, 3, 4, and then we will use these dots because their terms or their elements are not ending. They are non-terminating. So any set in which the number of elements are non-terminating, we use these three dots and then leave it as it is. Likewise, this E is equals to 2, 4, 6, 8. And afterward, we don't write the remaining terms. On the other hand, the letter this epsilon is used for to belongs to, as I have stated. For example, A is an element of A. See, this A is an element of A. 2 is an element of N. 2 is an element of N. 6 is an element of E. 6 is an element of E. So we say that A, 2 and 6 are members of A, N and E respectively. The symbol this, if we use and like this, means does not belongs to, right? Say we have taken E is 2, 4, 6, 8. So 7 is not here. So we will write it as 7 does not belongs to E, because 7 is an element or a number which is not the member of E, that is set of even numbers. So any member which is inside a set, we will use this symbol, and if any member which is not the member of that particular set, we will use this symbol. So this means belongs to, right, and this means does not belongs to, does not belongs to, right. The second form is what? Set builder forms, right? Before set builder form remark, we do not list an element more than once in a given set. Repetition of elements in a set is not allowed. We will write down an element only once. Thus, A, B, C, this set, and A, B, B, C, both are same, denotes the set of different words. Like C, A, B, or A, B, C, both are same because ordering is not important. So when we are listing the members of a set, the name of a member is listed only once, and the members can be written in any order. Order is not important. The second type is what? Set builder form. In this form, a set is defined by stating properties which the elements of a set must satisfy. We use this the same way, this brass or bracket, to write sets in this form. Here we write the condition which X satisfies, or more briefly, we write it like this, say X and then Px, right? Where Px is a proposition stating a condition on X. Look at the example. Thus, if we write A is equals to X and say X is even, this is how a set can be represented, and this form is known as set builder form. What does it mean? The set A is equals to X, X is even, so the element of the set is X, right? But X is what? All the even numbers. So we can write in the first form, this can be written as 2, 4, 6, 8, 10, 12. See, both are same sets. A is equals to X, X is even number. It means A is the collection of all even numbers. So this can be written as this way also. So this is the case 1, first way, or first method. This is the case 2, or second method, how a set can be represented. Another example, a collection of numbers 1, 3, 5, 7. See, this one. 1, 3, 5, 7. All these numbers are odd. So we can write it, the set A is equals to X. X is an odd number, right? It means the set A is the collection of all odd numbers. Clear? The solution of the equation x square minus 10x plus 24 is equals to 0. What does it mean? This can also be written as in the form the set x, for example, is equals to x, and then x square minus 10x plus 24, this is equals to 0. What does it mean? The set is X contains only those values of X which satisfies this equation. Clear? Now this is a quadratic equation. You can find out its solution. So naturally it will have two roots. So you will get two values of X. So the set will contain only two values which will be considered as roots of this equation. But this is how we read. X is a set of those members which are solution of the equation x square minus 10x plus 24 is equals to 0, right? Finite and infinite set. This is the classification of a set. Means if we have a set, it can be classified in two categories. Number one is finite and second is infinite set, right? A set is said to be finite if it contains finite number of elements. Means if the elements are easily countable, Otherwise, it is called infinite set. If a set contains uncountable or non-ending elements, then we call it as infinite set. For example, if I say the set A is equals to A, E, I, O, U. This is the set of vowels. It contains 5 elements. So it's a finite set. If we write P is equals to A, B, C, and then up to Z. P is also a set consisting of 26 elements. That is all alphabets of English literature. This is also a finite. This is finite. This is also finite. On the other hand, if we write N is equals to 1, 2, 3, 4, and then so on, look at this example. The set N contains non-ending elements. Their terms are non-terminating. Therefore, N is called an infinite set, right? Are you getting the point? As well as Z, Q, and R, they all are standard examples of infinite sets. Infinite sets simply refers those sets which contains uncountable or infinite many elements, right? Then another criteria or another type of set is called unit set. A set containing only one element is called a unit set or singleton set. Means any set, if I write a set X is equals to say A, this is a set containing only one element. X is called a singleton set or unit set. For example, the example taken here, look at this. If we write a set like this, A is equals to X, right? And X minus 2 is equals to 0. What does it mean? First understand this example. Set is A is what? A contains those elements X which are solution of this equation. So how many solutions of this equation x minus 2 are there? Only one. X minus 2 is equals to 0. It means 2 minus 2 is 0. So x is equals to 2. So the set A will contain only one element, that is 2. That is why this is called as singleton set or unit set. Second thing is empty set or null set. A set which contains no member is called the empty set or null set. For example, the set of months of a year that have fewer than 15 days. Are you getting the example? The set of months of a year that have fewer than 15 days. Do you have any month in a year which contains less than 15 days? No. We don't get any month. That is why the set of months of a year that have fewer number of 15 days has no member. Therefore, it is called an empty set. Generally, empty set is denoted either by this or a Greek word, Greek letter, which is known as phi. We denote it like this and we write it or read it like phi. So empty set or null sets are being denoted either by this brass bracket or by a Greek letter phi. one should understand the remark, it should be noted that zero and empty sets are not the same. Zero is a number and might well be a member of some set. For example, this zero is not an empty set. Also, for example, what this statement, what this remark actually refers to. It should be noted that zero and empty sets are not same. Zero, if I write this zero, one thing. If I write zero like this is another thing. Here in this case, zero is only a number, right? But here in this case, zero is a member of a set, right? This is a set. If we denote A is equals to this, what we will do, what we will say, A is a set having one element, that is 0, right? This is a set. But here A is only a number, 0 is a number. This is the difference between 0, this 0 and this 0. Second thing, phi. Phi is a set which is called empty set or null set. So null set means a set which doesn't contain any element. A set which doesn't contain any element. The one thing, see the difference, this is phi. Simple phi is generally a notation of a null set or empty set. If we write like this, see, are you getting the difference between these two? This is the notation of an empty set phi, but here what is this? We write it say like this, A is equals to this. Now phi is treated as an element of the set A. So A is a set having only one element phi. We can call it as a singleton set. Singleton set means a set which contains or consisting of only one element. So this is the difference between this 0 and this 0. Here this 0 is only a number, but this 0 is an element of the set. Likewise, here this phi is only the simple notation of a null set or empty set. But if we write like this phi is a member of a set. That is, a set is containing only one element or only one member, that is phi. So students, hope this is more than sufficient for understanding the concept of the set and their variety, finite, infinite, then unit set, then empty set. This is more than sufficient for you people to understand the subsequent text. So thank you very much.